discuss that what is your Voronoi diagram first. Actually, a Voronoi diagram is the way to partition a plane. Partition a plane into region based on the distance, to a given set of point. Okay?
Yeah.
Means actually Voronoi diagram is nothing but a process in which we are partitioning a plane into region based on the distance to a given set of points. It means in each and every question of this chapter, we have some points. We have some given set of points, and then by using some distance and all these things, by using some different formulas, we are just dividing your plane into some regions. Okay?
Yeah.
So that region, each region corresponds to the area closest to a specific point. Known as seeds, or you can say that generator. Means whatever the set of points, independently each and every set of point we can call as seeds or generator. Okay? Actually, Shanvi, this is the very important application in many different subjects. Like I can write like geometry, we can use this topic. Actually, this is the part of geometry. In geography, we can use this topic. Okay?
Okay.
In biology, we can use this topic. In computer graphics, we can use this topic. After that, in robotics, we can use this method. In optimization, we are using this. And even as well as your visual arts, or you can say that art and design, you can use this. Okay. So this is very important topic. And one more thing, this is again an important topic if you are interested in this topic. So you can go ahead with any topic which is related to this Voronoi diagram for your IA as well. Okay?
Okay.
Actually, in short, your Voronoi diagram is the way to apply your theoretical knowledge.
Okay.
Theoretical knowledge to practical situations. Okay?
Okay.
Whatever the situations is there with you, you can apply your theoretical knowledge on that practical situation and gain insight. For what? And gain insight into real world scenarios. Okay?
Okay.
This is your theoretical part of this topic. Correct?
Correct.
After that, we are going to learn 5 important things in this chapter. The first is, what is your Voronoi diagram? We have already discussed, in fact, but we have discussed only definition. But how we can, what is the meaning of this diagram? Okay,
Yeah.
In mathematical form. Construction of your Voronoi diagram. I write VD. Okay. And adding a site. Site means adding a site to a Voronoi diagram. And the fourth one is nearest interpretation, we can say that. Nearest neighbor interpretation, okay? Interpretation. Correct?
Yeah.
And the last and the most important thing, the largest empty circle theorem. The largest empty circle theorem, okay? And toxic waste dump problem. Okay?
Okay.
Actually, this topic is related to this practical problem, this application, this real world scenario. That scenario is known as toxic waste dump problem. Okay?
Okay.
So I'm going to start with first topic, and that will be your Voronoi diagram. Clear?
Yeah. Okay.
And if you are here with me for 2 hours, so I can complete this whole chapter by today only.
Okay, ma'am.
Voronoi diagram, because it's quite easy. You can do
Okay.
each and every question. Voronoi diagram means what? Before proceeding further with the definition of Voronoi diagram, actually the Voronoi diagram including many important key features, and those key features, the first key feature is known as site. Okay? And the second important key feature is cell. I can write later on. The third one is edges, and the fourth one is vertices. So we have 4 important key features in this Voronoi diagram. The first one is site, the second one is cell, and the third one is your edges, and fourth one is your vertices. Okay, before proceeding further, I'll take an example so that you are able to see that what it is. Okay, actually Voronoi diagram mein kya hota hai, Shamli? We are just taking some points like that. Okay, I'm not using these number of, I can use only, suppose I'll use these 4 points for you. Okay, clear?
Yeah.
So what I can do it, I just need to join each and every point first, like that. Okay, suppose this point is A, and this point is B, and this point is C, and this point is D. Sorry, we need to make it this as C and this as D. Okay, correct? We need to take, I think you remember, initially we'll take the set of points. So this is your set of points, A, B, C, D. Okay,
Right.
and these set of points are known as site. This. Yeah.
Yeah.
Actually, before defining with the theoretical definition of all these 4 key features, I just need to explain you with the diagram, so that then you are able to get your theoretical definition very easily. Okay. So initially the step is to take 4 set of points, and that 4 set of points are known as site. Okay. Now what you can do? You just need to make a perpendicular bisector on each and every line. Okay, so I think this is your perpendicular bisector of each and every line, right?
Yeah.
Perpendicular bisector means you have to put a line which is perpendicular to each and every line, and this point must be a midpoint. Okay,
Yeah.
correct.
Right.
Now you just need to erase these joining points, whatever the joining points are there, with the sides. Okay,
Right. Okay.
so after that, I think it is clear that the point of intersection of all the perpendiculars of all the sides is known as vertex. Clear?
Clear.
And this A, B, C, D is your site. This is also your site. Clear? This is your site. And this is your site. Clear? So I think site and vertex is clear to you. Clear?
Yes, ma'am.
And all these bold lines, all these bold lines, whatever the perpendicular is there for all the lines, these are known as edges. Okay, clear?
Yes, ma'am.
And whatever the area, this area in between 2 perpendicular, this is known as This is known as this. These are your cells. Clear? So you can say that this area is known as cell A, because in this area, point A, the site A is lying in this region. So you can say that this is cell A, this is cell B, and this area will be your cell C, and this area will be your cell D. Correct?
Yes.
Any doubt?
No, ma'am.
Okay. So I'm just erasing this figure with you, and then I'm going to write. Okay, now I'm not erasing. I can write the definitions for you one by one, and then you can tell me, did you get it or not? Okay.
Okay.
So the definition of a site, I write. I don't think so that I need to repeat this definition. You are able to understand each and everything.
Yeah.
A site refers to a specific point in the plane that serves as a reference or generator, or you can say seed. Okay.
Yeah.
For the diagram partition. Okay.
Yeah.
Clear?
Right.
Means actually to partition process, we need these seeds, we need this site. Then we are able to make a perpendicular, then we are able to make a regions, then we are able to make a cells. And the point of intersection of those perpendicular is known as vertex, right?
Right.
Did you get the definition?
Yes, ma'am.
Okay, now I write the definition of a cell. So the definition of a cell will be each site means ABCD, okay, is surrounded by a region.
Ma'am, you'll just give me a second. I'll just take this call.
Sure.
Yes, ma'am.
You can read this definition.
Okay. Each site is surrounded by a region which contains the points which are closer to the site than to any other site. Like, okay. Like the cell which contains A is known as cell A.
Right?
Right.
Like the region.
Yeah.
To say cell, we need to define cell, na? Like the region which contains A is known as cell A, right?
Right.
Shanvi, if you are not getting the point, it's okay, you can tell me, okay?
No, I got it. Yeah.
Okay. So the third one is your most important, edges. If it is clear to you, then you can tell me the definition of this edges now. Okay, the line which separate the cells
Okay.
are called edges, correct?
Correct.
Right?
Yeah.
The fourth definition now. Vertices or vertex, you can see. So I write the point at which all the edges meet are known as vertices. Correct?
Yes, ma'am.
Any doubt?
No, ma'am.
Okay. Now just give me a second. I need to start with this. So I'm pasting one question for you so that you are able to recognize what is the meaning of this. Okay. This is your question. Is this question visible, Ranvi?
Yes, ma'am.
Consider the Voronoi diagram for the sites A and B. This is your A site, okay? This is your B site. This is your C site. And D site is as well, okay? How many cells does the diagram contains? You tell me first. How many cells are there?
Ma'am, can I see the definition?
Absolutely.
Okay, got it.
Tell me now, how many cells are there in this figure?
Three.
Absolutely right. Okay. So this is your first cell, okay?
Right.
And this is your second cell, right?
Right.
And this is your third cell, correct?
Yeah.
So number of cells are 3. Tell me for B part.
How many
vertices does the diagram contains?
Ma'am, what is the vertices?
The definition of vertices is what? The point at which the edges meet.
1.
Why 1? 3 vertices.
Oh, the edges meet.
The edges. This is your edges meet. This is your
Yeah.
edges. This is your edges meet. So 3 are.
Yeah. Right.
One more thing. Actually, in this, we don't have cell 3. We have cell 4, right? This is also a cell, now. This D point is lying inside.
Yeah.
This is also a cell, okay?
Oh, right.
Also a cell because D point is lies inside this triangle.
So we have 4 cells.
Yes, we have 4 cells. If this D point is not there inside this, then you are not supposed to consider this as cell, okay? Because the definition, see, each site is surrounded by a region or a cell which contain the point. Correct?
Yes, ma'am.
Which contain the point. So this region is also contain the point D, no?
Right.
Now, how many vertices are there? There are 3 vertices, right? Tell me for C.
Identify the site closest to.
Means tell me this point is lies in which cell. That's it. Or which near to which site. See, 2 and -3. I'll tell you one, then you can tell me other, okay? 2 and -3. So 2 is on x-axis. So this is 1 and this is 2. Correct?
Right.
and minus 3 is on y-axis. So
Right.
1, 2 and minus 3. This is your minus 3. So what is the point? This point. This point is known as 2 and minus 3, correct?
Right.
So this point is lies near to B, correct?
Okay, so for 1 and 5, 1 and 5 is on the x-axis,
Tell me
right?
where this point lies. This is your 1, right?
Yeah, and that is the 5, so it's the closest to B.
Where is B? It's closest to A.
Oh,
Yeah.
okay, right. But then x-axis also has 1 and 5, right?
You are not supposed to find 1 for 1. You just need to find for 1 and 5.
Okay.
Where this point lies, 1 or 5. This is the point, no?
Yeah.
So why you are considering for 1 only, no? This is your point. Okay. Minus 2 and minus 1 and minus 2. Don't find minus 1 or minus 2. Find minus 1 and minus 2.
It will be the closest to C.
Absolutely right. Okay, minus 1 and minus 2. So this point lies here. How it is closest to C? This point lies on the edge. Now I'm telling you one important definition. If any point lies on the edge, then you can check that that point lies on, it is equal to C and it is equal to D, correct? Why? Because this point lies on the edge. Which edge? Which is perpendicular to the line CD, correct?
Right.
Again I repeat, there is a line CD and I am putting, this is your perpendicular on CD. That is why this line is known as edge, correct?
Right.
And that this point lies here, that point is minus 1 and minus 2. So in C part, what you can write, minus 1 and minus 2 lies on the edge adjacent to cell C and D, okay?
Yeah.
Okay. And which is equally spaced between C and D, correct?
Correct.
So in that type of point, you are not supposed to say A or any particular point. That if that point lies on the edge, then it must be near to 2 points. But you need to check that that point lies on which perpendicular, okay? Clear this question or not, Shandu?
Yes, ma'am.
Now the question is, what can we say about the point which lies on the green edge? See, this is your green edge, see? Visible?
Yeah.
So if any point lies on this edge, then what you can say? See, if that any point lies on this line, it means this line is perpendicular to A and B, right?
Right.
So it means if any point lies on this line, which is always equidistant from A and B. Clear?
Clear.
So what you can say that in the part, that if any point lies on green line, it means that point is equally near to A and B, okay?
Yeah.
Correct?
Yeah.
Any doubt?
No, ma'am.